Today we're going to discuss the Pythagorean theorem and what it means when you're solving or looking for a side of a right triangle. With the Pythagorean theorem, as you heard from the Brain Pop video, it was developed by a group of people called the Pythagoras. Now, they're way back in time, so they didn't have numbers and like calculators and all that stuff. So way back in time, what they did was they took rope and they knotted it off equally to develop how much land you were going to buy. And for some reason, they always did this land in triangles. And they realized through a series of calculations, or their calculations, that there was some kind of coincidence that happened with this Pythagorean theorem. And with that, they developed the formula that said that c squared equals a squared plus b squared. Now, what does that mean? Well, first of all, we need to think about our right triangle first. Right triangle means I have one right angle. With that one right angle, the first thing we need to realize that the A, B, and C in our formula go to the different sides of the right triangle. We're not talking about angles, we're talking about sides. So, how do we determine who A and who B and who C are? Well, A and B are what we call the legs of the triangle. With the legs of the triangle, they sit around the right angle. It does not matter who you call A and who you call B. It's just important to know that they sit around the right angle. Then we have what you call the C. The C is what we call the hypotenuse. The hypotenuse, oops, sorry, that's USE, is always directly across from the right angle. It is also the longest side of my triangle. It's always the longest side because it's the diagonal, and the shortest distance between 2 points is a straight line. So with this formula that says c squared equals a squared plus b squared, we can determine, one, if I have a right triangle, and two, what one of the missing sides of my right triangle is. I can only use this formula when I have a right triangle. And when you're in geometry, you use this formula 5 million times. Okay, so let's look at the formula. First thing it says, I want to find the length of the hypotenuse of a right triangle if A is 12 and B is 5. Those are just my sides. So we know that our formula says that c squared equals a squared plus b squared. All right, so the first step to solving any formula is substitute my values in. I am looking for c. I don't know what it is. So c squared equals a squared plus b squared. Just like any other equation, I can't do anything with this c squared until I've simplified my side. To simplify my side, I'm going to have to square 12 and square 25 and then add them together because that's what order of operations tells us. So once I've simplified the side, and I'm left with c squared, because no matter how I solve an equation, I always try to get my variable alone. But now I've got to get only one piece of my variable. Nobody cares about c squared, we care about c. But I have to get c squared alone before I can do anything with just c. So if I'm squaring c to get 169, how do I get plain old c? Exactly. It's a square root. If I take the square root of c squared, the square and the square root cancel each other out, and I'm left with plain old c. But like every other equation we do, I have to do it to both sides of my equation for it to be legal. So now if I go to my calculator and I hit second x squared, because that's where I get my square root, same place that I got it when we did the quadratic formula, I put 169, I put equal C equals 13. And if it had a units, I'd put a units on it, but it doesn't, so I can't. This is my final answer. I have found what C solely does. So let's recap really quick before we move on. So it says right here, my formula, which I'm going to write when I solve my problem. I'm going to substitute. So the first thing I did was write my formula. Second thing I did was substitute my values. Third thing I did was simplify. And the fourth thing is I took the square root to find missing variable. It's not always going to be C. So we give you a second to write that down. Then we're just going to practice, 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 practice. All right, number 2 is a little bit different. It says, to find the length of a side A if B is 9 and C is 21. So A is over here, B is 9, and C is 21. How do I know that the 21 is C? Well, besides in the directions, hello. But it's right across from my right angle, and C, my hypotenuse, is always directly across from my right angle. Oops, sorry. All right, so now, first step we said was to write our formula. So, C squared equals A squared plus B squared. Okay, second step says substitute into my formula. So, I know that my C is 21. I know that my A is what I'm looking for, and I know my B is 9. Now, just like my other thing, it says I'm going to simplify now. I need to go ahead and simplify these numbers. So 21 squared, A squared, and 9 squared. Now, I have to get my variable alone. So to do that, I'm going to get rid of the 81. I haven't done anything with my C squared, my A squared yet, excuse me. Now, I'm going to take the square root to get rid of the A squared. And you're going to notice that it's not perfect. I'm just going to write this out here first like this. That's what my calculator gives me, about 18.97, blah, 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 blah. There's two ways, and it says to round to the nearest hundredth. So I'm going to leave it like that, but I could simplify my radical, which we did back before. We'll talk about that later, but distance is typically a decimal, so we can leave it as a decimal. It's not always a decimal because we're in math class. Sometimes it can be left as a simplified radical. We will do that later because right now it says to round to the nearest hundredth. So here I'm going to round it. If it didn't say to round to the nearest hundredth, so this is what A equals, rounded to the nearest hundredth, because I don't know what went after it because that's where I stopped my calculator. That what if it said it wanted the exact distance, so I needed to leave it as the square root. I'm just going to come over to this side over here. I'm going to take this line right here, and I'm just going to bring it over here. It says the square root of 360 equals A, because it was the square root. All right, so remember when we simplified the radical that we first wrote this in prime factorization. Then, to get outside of my house, it takes 2. 2 make 1 on the outside. 2 make 1 on the outside. He's left, and he's left on the inside. And then I'm going to simplify. I would only need to do this if it tells me to leave my answer in simplest radical form. In simplest radical form. Not very often we ask you to do that, especially in algebra. In geometry we do, but not all the time in algebra. So a lot of times it'll say to round to the nearest hundredth, or it'll say whatever. So a lot of times it'll do that for you. But if it says it wants an exact answer in simplest radical form, you would do that. I don't believe we're doing that today, but that's okay. You know how to do it, nothing new. This next question is a little bit different. It says it wants to determine if the following side measures would form a right triangle. If it forms a right triangle, that means Pythagorean theorem is true. Which if Pythagorean theorem works, it means c squared equals a squared plus b squared. That means it's a right triangle if both sides are equal. All right, so looking here at 6, 8, and 10. First, C has to be my longest side. Why? Because he is my hypotenuse. The hypotenuse is always my larger number. Yes, they look like they're written in order, but we're not going to guarantee that life's going to give us everything in order, all peachy and happy. So you have to look at the numbers and say, okay, he's C because he's my longest side. A and B just pick, because it doesn't matter mathematically who is A and who is B. All that matters is one of them is A and one of them is B around the legs, and the two that are left will be my legs. My hypotenuse is the guy that counts. All right, so I'm going to take this and I'm going to plug it in to the Pythagorean theorem. So the Pythagorean theorem says c squared equals a squared plus b squared. So 10 squared equals 6 squared plus 8 squared. Clean up my math. Oops, that's 100. Sorry, that's cleaning up my math. Yes, this is true. Yes, it is a right triangle. No, this is not true. No, it's not a right triangle. That simple. You do B while I do B. Check your work when you are finished. Pause the video if you need more time. Okay, number 4 just says determine the length of the hypotenuse for each triangle. So again, what we're going to do is we're A, we're given B, we're going to try to find C. C is our hypotenuse. So, you work 4 while I work 4. Check your answer when you are done. B is a tiny bit different. How come? You got to know how to deal with this guy here, okay? So, math-wise, he's not bad. I'm going to work him over here. Problem number B. again, we're still trying to find C. Again, we're just going to substitute in what we know. Notice how I put him in a parenthesis. If on your calculator you do the square root of 23 squared, remember, they're the inverses of each other, so the square of the square root is just the number under the radical. I'll say that again. The square of the square root is just the number under the radical. But mathematically, if you're putting it in the calculator, again, you need to be very careful. Because remember, you've got that extra parenthesis. You've got to get out from under the parenthesis before you square it. So you need to have the square root, give it an end parenthesis for that, go out and square it. Okay, remember how that looks on the calculator. You have your square root. It gives you the imaginary parenthesis. You have the 23. You're going to have to end the parenthesis, move over, and then put a parenthesis to square. It's different on the calculator. Perfect. Okay, on number 5, all we're going to do now is look for the missing leg. So, same idea, same consequence, except for now I'm looking for the missing leg. I'm looking for B. So again, write my formula. I'm going to plug in what I know. Oops, sorry. Yeah, I plugged it in with my brain too far. Sorry about that. Plugged it in my brain too far. I went ahead and evaluated it. I didn't want to evaluate it yet. Sorry about that. Now I want to evaluate it. Need to bring the 16 over. Get rid of the square. Okay, two things going on here. 1, I have my radical. 2, I can simplify my radical, or I could put it as a decimal. For purposes right now, next year we will leave things in simplest radical form. For now, let's go ahead and make them decimals, just because of the mere fact we'll round to the hundredths. Just because for the introductory right now, we don't need to do it in simplest radical form, although it's very easy to do. We're very, very smart. I just rounded to hundredths. Just rounded to hundredths. Oops, sorry. Not paying attention there, I apologize. Okay, and go ahead and do B. I should see every step on your paper. I should not see any shortcuts. You put shortcuts, I take points off. And again, I just rounded to hundreds. I could leave it as the square root 11, but I'm going to go ahead and simplify that to make it a number. Next year, you'll have to leave some things in simplest radical form. This year, you are just going to put them in decimals. It's fine. All right, our next example is actually a word problem. You'll have a few of those as well today. It says, I want to find the length of the diagonal of a rectangle whose length is 8 meters and width is 5 meters. First, we need to get a visual. I'm going to draw a rectangle. It says that my length is 8 meters and my width is 5 meters. and I want to know the length of the diagonal. That's a diagonal. Goes from corner to corner opposite. Which is going to be my C because he will be my right angle in the right triangle. Excuse me, in the right triangle formed in the rectangle. So, I've identified my parts. I wrote my formula. I substituted in. Does it matter who I call A and B? Certainly not. And we're going to go ahead and round again to hundreds. It's a word problem. I should have units on my answer. I have meters. It is meters. Now my last one here is going to take everything we know into account. Okay? Yes, these are variables. You have one of these in the practice we're going to do today. I believe it's 14, but I'm not sure. I might have the paper in front of me. Is anything different in this problem? Not really. I just have an expression for the side. No big deal because I'm super smart and I can solve it. Again, I know that this is A and B, and I know that this is C because he's directly across from my right angle. Again, I know that C squared equals A squared plus B squared. I'm just going to have some ugliness to deal with, but you know what? Again, I'm super smart. So, I'm going to plug in. I've done nothing but plug in my sides. All right, so I have this expression I'm squaring. Again, it basically looks like a PST. This means 2x minus 1 times 2x minus 1. I'm going to have to do what to solve that? Exactly, I'm going to have to FOIL. Here, that means x plus 1 times x plus 1. So again, I'm going to have to do what to solve that? Exactly, I'm going to have to FOIL. So let's go ahead and FOIL this first one. So I get 4x squared minus 2x minus 2x plus 1. I remember FOILed first, outer, inner, last. I'm going to FOIL again. X squared, x, and 1. Now, because I'm a good math student, I'm going to clean this mess up. So, 4x squared minus 4x plus 1. X squared plus x squared is going to be 2x squared plus 2x plus 1. All right, we just had a test that had ugliness like this on here. It's going to be a quadratic. To solve my quadratic, I have to set this whole thing equal to what number? Exactly, I've got to make it all equal to 0. So, I'm going to bring my 2x over by subtracting 2x squared, so my 2x squared over, which means I'm going to subtract 2x squared here. I'm going to bring my 2x over by subtracting 2x. And I'm going to bring my 1 over by subtracting 1. Again, I had to have it equal 0, so to get rid of my 2x squared, I subtracted it. To get rid of my 2x, I had to subtract it. To get rid of my 1, I had to subtract it from both sides. I cleaned it up. Now I'm going to clean it up a little bit better because that's 2x squared minus 6x equals 0. All right. Solve by factoring. What am I going to do first? You got it, GCF. So to do the GCF here, I'm going to take out a 2x, and I'm going to be left with an x minus 3. Just had a test on quadratics, so how do I solve that? Exactly, each piece gets set to 0. Solve mini equation. Now, when I'm looking at this answer, there's a reasonability answer in geometry, and there's an answer to my factoring problem in geometry. Here, can x be 0? You're right, it can't be. If I plugged in 0 here, it means my side is 0. It means my side is 1, and my side is going to be negative 1. Can you have a side of a polygon that's negative? No, I don't know what that would look like. So he's called what we call, he's an answer to my factoring problem, but he's called like, he just kind of goes away. It's kind of like when that 5 equals 0 mess. He just kind of goes away because he can't be a realistic answer. It just doesn't, it just can't happen. So the only true answer to my problem is x equals 3. Because he has to kind of just disintegrate because he can't really happen. He works for my math, he doesn't work for my triangle. So my answer is only x equals 3. He's the solution. Again, I just squared each side. Again, I just FOILed. I grouped all my terms to the one side to equal 0. Want to keep my x squared positive. Then I just GCF'd, set each equal to 0, and solved. All right, now what you're going to go ahead and do is you're going to work on some practice problems. You can work with a partner to do them. It's up to Mrs. Todd if you're going to go ahead and work with a group of 4. No more than 4, but if you work in a group of 4, you're going to work in your pods, not random groups of 4. You'll work in your assigned pods of 4. Otherwise, you can just work with your shoulder partner, and you're going to complete evens on the sheet. Now, we will do this sheet again after spring break, so do not get rid of it. We're only doing the evens now. Later, we will do the odds, and I will collect it then for a classwork grade. Okay? Any questions? Ms. Todd is super smart. And if you need me, you can't see me because I'm in a meeting. But anyway, go ahead and work in our groups and make sure you show all of your work. We'll check at the end of class.